Besides a monstrous revelation made by means of the James Webb Space Telescope, city lights contraptions in space saw 7 trillion miles from Earth. This tremendous finding has ignited interest inside the chance of extraterrestrial life. The telescope zeroed in on Proxima Centauri b, the closest exoplanet to Earth, uncovering eminent, unbelievable lights transmitting from it. What can be the explanation for those town lights on Proxima Centauri b? Could this later on signify the presence of life beyond our sun's gadgets? As we delve into how the James Webb Space Telescope has observed these top-notch things in space for an extended time, specialists and everyone have speculated about existence beyond our close planetary neighborhood, suggesting life has been restlessly expected. Truly, the scientific association became striking over areas of solidarity, for while living elements were seen by the James Webb Space Telescope while concentrating on the region and sending critical data back to Earth, the James Webb Space Telescope implied hard-to-ignore city lighting shining from the exoplanet Proxima Centauri b. These lighting contraptions have been accurately, as their name forewarned, lights like those illuminating a city. The opportunity of an outcast city present on the tremendous name has left specialists confused and befuddled, as it seems to be the means of life they have all been expecting. Expecting that this is apparently real, as one and all believes it will, it pushes toward the notion that there are sensible living animals building progress new to what people sort out in space. Furthermore, we are simply going over it, researching the city lighting mechanical assemblies arranged 7 trillion miles from Earth. NASA makers can't resist the urge to think about how broad those lights have been found in district. David Kipping, a cosmologist from Columbia School, describes the Proxima Centauri b exoplanet, in which the town lighting establishments were arranged, as charming. He communicated so due to the truth that the star system closest to us has changed for styles that aren't like different planets. The normal rocky planets are known to soak up daylight and transmit infrared radiation, but not so for this exoplanet, as its infrared nature is particularly first-class from that of its host star named Proxima Centauri. This requires an immense observational eye through the James Webb Space Telescope, JWST, and the telescope turned out to be useful as the authentic contraption for the task. The JWST can undoubtedly understand infrared frequencies, the moment energy natural for Proxima b, which can be a central part in uncovering the spread-out special bits of knowledge of its ongoing situation. This could be executed thanks to the present time of infrared imaging capabilities advanced through the JWST. Specialists need to apply the telescope to find the normal pieces of this planet at air levels. They also plan to use the Webb telescope to investigate the chances of life on this exoplanet. The James Webb Space Telescope has an infrared awareness that is equipped to take apart what happens on Proxima Centauri b, given its capability to get the smallest sensitive outpourings in the unfathomable haziness. This is frequently very challenging for district telescopes, but not for the JWST, as it can view even the littlest sensitive releases from space. It's an awesome contraption to check if the studies about city lights on Proxima Centauri b are significant or not. Only 1 out of every odd-made light inside the universe can be perceived by using the telescope, as long as it falls inside a frequency band that is frequently more modest than the TIE. Proxima b has an empowering chording among its heavenly substances and floor conditions. The day part of the exoplanet consolidates different sun chargers that tackle the impacting sun energy released through the star, even as its supernatural region mirrors incoming light bars in the interval exactly when Proxima b completes its circle around its host star, Proxima Centauri. It reviews continually cycles a lot like what we have on Earth, with the sunlight hours having high sun significance and the 12 p.m. experiencing coolness. The planet is thought to have temperature variations coordinated through its shape. For example, assuming there may be no atmosphere on Proxima b, the differentiation between its day and 12 p.m. cycles can be monstrous and some distance apart. Assuming there is no controlling effect of ecological gases in oceans, the temperature of the day point of view can be sizzling hot like a faint edge, and the 12 p.m. will plunge into the cool fogginess. The degree of temperature variation is a prepared concern for cosmologists to determine a more significant ability of the Proxima Centauri system. Having an unmatched infrared imaging ability, the JWST can indeed notice the planet's warm outpourings to offer sensible insights about its regular homes. Clearly, the circle of the James Webb Space Telescope around the Earth lines up with Proxima b's orbital term, giving a total viewpoint on its 24-hour cycles within 11.2 Earth days. Assuming it for sure has an atmosphere, The following step could be to determine its regular imaginative capacity to choose if it can uphold life. Some quality signs in seeing whether there is a presence are the presence of gases like oxygen, water vapor, and methane. Assuming those parts are tracked down on the world, it shows that it maintains possible conditions for life. The task of absolutely recognizing this calls for examiners to be fussy as they assemble and examine light bars that go through the planet's ecological components. That is an absolutely hard mission. However, the JWST has unbelievable capacities for depicting planetary conditions. It has a fundamental objective. The telescope has been programmed to best gander at the assortments in water vapor, carbon dioxide, and methane mindfulness. While it comes to recognizing further developed oxygen, which is a critical sign of something occurring far underneath, the JWST is restricted around there. Albeit the telescope, all things considered, has key inspirations to search for changed parts inside the overall like ozone, which gives a wonderful degree of importance inside the air. The true fact that the James Webb Space Telescope doesn't have total capacities and can't peer at most likely the nearest conceivable universes to Earth, leading in careful air examination, space specialists are currently leaning towards ground-based observatories like the Extremely Large Telescope (ELT). The ELT is a telescope that has been planned to begin working in 2028, and its far conclusively spot to look more significant into the barometrical association of remote exoplanets. It will offer data on those planets to provide total and clear pieces of information into their degree of reasonableness. NASA scientists and all people are energetically searching for the association of future space telescopes like those. Until that moment, however, the James Webb Space Telescope remains a critical gadget in our journey to find the secrets of far-off exoplanets. Not urging its advancing limits, the NET telescope has the ability to provide beast pieces of information that will change how we interpret exoplanetary focuses on now and in the future. Experts have an objective for future space telescopes, which is to reduce the amount of wonderful delicate coming from a planet's host star so stargazers can all the more likely see the lighting considered from an exoplanet itself. They aim to endeavor this using internal sun concealers or gigantic outside sun-powered sun hides formed like an umbrella, akin to using your hand to close out light discharges to permit you to see a thing clearly. Reducing the amazing splendor coming from the host star will better position future telescopes to zero in on faint impressions of light coming from exoplanets, considering the ideal examination of its organic framework and the possibility supporting ways of life. Doing this goes with its challenges, however, as researchers need to understand gases contained in life and those from land cycles like volcanic activity. Space specialists are not leaving, grasping the characteristics of exoplanets so they are better prepared to assess results on a more significant level and differentiate them from interesting signs. The JWST represents all the while an explosive open door. A staggering story has emerged recently that a couple of outcasts are indeed something particularly incredible inside the stars, simply believing that individuals will track down them to provide a reaction to this inquiry. American space experts Jill Tarter and Thomas Pearson began a mission called the Search for Extraterrestrial Intelligence, SETI study in 1984, considered the SETI Association. It's a generous affiliation that means to channel through grandiose signs to clearly get radio transmissions from space. The point behind spending critical time in radio transmissions is due to their ability to travel immense ranges without getting dissipated or absorbed like various types of radiation. By virtue of this, radio transmissions are sure to be perceived through the 42 radio telescopes that make up the Allen Telescope Array arranged in the lower districts of California. Despite the fact that the SETI Association has not permanently set up signs of radio transmissions made by extraterrestrial life, there have not been such signals for more than 30 years. The way that they will makes Jill Tarter moved to have a positive outcome, as they intend to utilize the contraptions of the 21st century to get the speed of the chase in a manner that would sound normal to Jill. She hopes that you could allow Earthlings anywhere to become eager individuals within the end mission for extraterrestrial intelligence. All of this happened until recent reports from NASA suggest that the James Webb Space Telescope found city lights from a planet near Earth. The JWST is the game-changer used by individuals in exploring the universe. It is at this point the most remarkable device in all of humanity to reveal all of the secrets of the universe. The telescope is at this point floating around 1 million miles from Earth, sending exact pieces of information concerning the earliest events of the universe. It's far expected to get the as-of-late diffused encounters seeing space as it conveys more on the advancement of space, worlds, and stars. Ologists haven't forgotten to benefit from the JWST's bleeding-edge upgrades, which may include the noteworthy finding of city lighting from Proxima Centauri b. A splendid new road could be opened up for exploration, and this can all be provided a response or more depending on the accuracy of ongoing work, which will decide how extraterrestrial existence was verified to its best level. This discovery may fundamentally alter our understanding of the universe and the potential for life beyond Earth. The James Webb Space Telescope, JWST, stands as a pivotal tool in this exploration, pushing the boundaries of what we know about distant exoplanets and their atmospheres. By studying the spectral signatures of exoplanets like Proxima Centauri b, scientists aim to unravel the mysteries of these far-off worlds, looking for signs of habitability and life. The telescope's advanced instruments, capable of detecting subtle variations in light and analyzing the chemical composition of distant atmospheres, play a crucial role in this endeavor. However, the task is fraught with challenges. The vast distances involved and the complexities of interpreting data from such remote sources pose significant obstacles. Nevertheless, scientists remain dedicated to their quest for knowledge, using the JWST's capabilities to their fullest extent. As the JWST continues to explore the cosmos, it holds the promise of uncovering new discoveries and reshaping our understanding of the universe. Whether it will reveal the presence of extraterrestrial life or unveil new mysteries remains to be seen. One thing is certain: the journey of discovery is only beginning. The JWST represents a monumental leap forward in our quest to understand the universe, and its findings could have profound implications for our understanding of life beyond Earth. Future space telescopes and ground-based observatories will continue this exploration, aiming to reduce the light interference from distant stars and enhance our ability to detect faint signals from exoplanets. Researchers are developing innovative techniques to achieve this, such as using internal sun concealers or large external sun shields to block out the bright light from host stars. This will allow telescopes to focus more effectively on the faint signals from exoplanets, improving our ability to study their atmospheres and assess their potential for life. The pursuit of extraterrestrial life is driven by a combination of scientific curiosity and the profound implications it holds for our understanding of our place in the universe. As technology advances and our observational capabilities improve, we are getting closer to answering some of humanity's most profound questions about the existence of life beyond our solar system. In summary, the James Webb Space Telescope has already made groundbreaking discoveries, such as the detection of city lights on Proxima Centauri b, that challenge our understanding of the universe and the potential for extraterrestrial life. As we continue to explore and analyze the data collected by this remarkable instrument, we are on the cusp of unlocking new secrets about the cosmos and the possibility of life beyond Earth. The journey is ongoing, and each new discovery brings us closer to unraveling the mysteries of the universe.